All right. Thank you, everyone, for coming. Just wanted to know by a show of hands who here is their first time being at a DigitalOcean community meetup. A few of you. Okay. So for those that aren't aware of what DigitalOcean is or does, we're a cloud infrastructure provider based here in New York City. We actually just celebrated our 5th year anniversary on March 5th. Yeah, thank you. Exciting times. So we have a pretty robust product roadmap ahead of us in 2017, and with that comes aggressive hiring. So if you're looking for a position, we do have several openings. There's some flyers over there that kind of gives you a little breakdown of perks, but you can feel free to use the iPads. There's one over there that has our careers page open, so feel free to scroll through and all that. Today we have Jay Gordon. He's from MongoDB. He's a developer advocate there, and he's going to be talking to us about cloud manager automation with DigitalOcean and MongoDB. It should be about a 30-minute talk or so. We'll have Q&A afterwards, and then some more eating, drinking, hang out, getting to know one another. So I'll let Jay take it from here.
How you doing, everyone? Thanks a lot for coming by tonight. I know it's a weekday and an evening, which means if it were up to me, I would have been home, probably on a couch with a dog. But we'll talk a little bit more about who I am and why I'm here. I used to work here, which is really awesome to come back here and talk to you all today, because I used to help build the platform that we're going to talk about running MongoDB on. And it's one of the reasons why I came here today. So I also worked at BuzzFeed for a little while, was a system administrator. I got to be part of a really insane night where nobody could tell what color a dress was. And that's how I kind of learned about MongoDB. Nobody could figure out what color a dress was, and in the process, we got a ton of traffic, and all that traffic was in MongoDB where things went right. We were able to collect all sorts of data. So we'll talk a little bit about what our topics are today. So we're going to introduce MongoDB. I'm going to tell you a little about what's under the hood. We're going to talk about what makes up MongoDB, and then we're going to talk about how you can configure using it using DigitalOcean. So I'm not going to do these things today. I'm not going to tell you some analogy about how MongoDB is like Mariano Rivera. It's not going to be that to you. It's not. I'm not going to say that other databases are bad. Why? To be honest with you, there's enough room in the world right now for a database to exist and work together with another database. So I'm not here to tell you, don't use this, don't use that. That's not why I came here. And I'm not going to code live, because nobody likes watching live coding. I'm sorry. It's just my opinion. So let's talk about the modern application. The modern application really has to have these kind of characteristics. We need high concurrency, because we need a ton of connections to use our application. We need high throughput, because it's got to be fast. Low latency, that goes right into that whole fast thing. Real-time analytics. If people are using our application, we absolutely want to know where, who, and we want to be able to do that as it's happening. There's no reason to get this information after it's already happened if you're trying to target people on a specific application. And it's got to be cost effective. You can't spend too much money. And like I said, I'm not going to badmouth other sorts of databases that are out there. But to be honest with you, licensing models on a lot of major databases that are in the enterprise world, they're beyond the actual startup capital expenditure that most companies can really put out there. And then no downtime. I mean, no downtime, that's everybody's application. It could be your favorite website to order pizza. It could be an application to figure out how to get to New Mexico. Either way, it can't go down. So that being said, we're going to talk about exactly what MongoDB is. And MongoDB is an open source distributed database. It's document based. So when I say document based, you'll learn a bit more, but it's a document database that provides you with high performance, high availability, and sharding. We'll talk a little bit about all those different bits as we continue on. MongoDB, in a nutshell, was written to make it simple to store data. And that's because there's no need to spend your time building a rigid schema. It's completely unnecessary for you. You just get started by writing your data. And to be honest with you, one of the huge reasons why people, at least in the world of operations, love MongoDB, is you can basically run it on nearly anything. It's built in C++, C, and JavaScript. These are trusted code bases that people really believe in to build fast, reliable applications. It runs, like I said, on just about any particular operating system that you're looking to run a database on. And we use what's known as an Afro GPL license. Basically, it's not very far off from what the Apache license is, but except if you make any changes to our code base, we do ask that you return it to us because we want to see and make sure that there's quality. If you want to fork it and use it yourself, you'll need to return that source code change to us. And drivers and frameworks. This is the core of what adoption was like for MongoDB. Without all these particular different idiomatic drivers that we made for everything, and the community did as well, we doubt we would have had such an incredible adoption rate from developers. The fact also that there are all these different types of web frameworks that people are using, MongoDB tends to be part of them, like Mean, Mern. They're all really, really rich and useful. So, like I said, we're going to talk about documents, but we're not going to talk about these types of documents because we're not talking about Word, we're talking about how our database is actually made up. So our database is using some similar types of information that we may already be used to when it comes to talking about relational database, but our actual database, still database, and our tables have been replaced by collections. Our indexes, still an index. Our rows are documents, our columns are fields, and rather than doing joins across multiple tables, what we're doing is embedding and linking. So your data will be stored in JSON style. And we all, at this point, if we're working with a lot of major data types that come from the internet, to be honest with you, JSON has become a regular standard. And documents themselves are rich data structures. Just to give you a little bit of information, you can see here, we've got a string, a number, a geolocation, all things that can be indexed against, by the way. We can have fields contain arrays to have multiple professions because obviously Paul is a very, very busy person. And he's doing pretty well because we can even take in this same document and add what kind of cars he successfully purchased because of his wonderful career in banking and finance. Good for him. And documents are flexible. When I say flexible, you can represent a product in a catalog with as much or as little information as you need. In this case, what we're showing is Acme Paint. And what does Acme Paint have? They've got red and green. Now we get over here, and not only are we going to just say that our t-shirt is heather gray, but we're able to give even more information that it's 100% cotton. And if we go over here, we'll see a same type of document, but even more information. And all this gets stored in a serialized type known as BSON. BSON is a binary serialization of JSON data. This is how actually you're not thinking about moving a whole bunch of text files because obviously you're seeing everything, it's in text format. That's the way we were talking about it before. Everything looked like a text file because it's JSON. But this is actually what it looks like when it's binary encoded. This is just a hello world. This type of format is stored together, and to be honest with you, it's easy to transverse across networks, and it's the reason why it's fast. Because to be honest with you, have you ever tried moving 1 million small files between 2 servers at the same time? Especially anyone here who knows Linux. It sucks. So what we did was we used binary serialization. And we have an expressive query language. We've got a ton of different types of query types that you can use because what we really like to refer to ourselves isn't just a standard NoSQL database, because just to be a standard NoSQL database would put us in the same place as you want to talk about the others like Cassandra and Hadoop. Like I said, I'm not going to badmouth what those do because what they do is great. But to be honest with you, it's so easy to work with MongoDB just grabbing files, or I should say grabbing documents with simple commands, because we've got a really, really simplistic way of accessing your data and then listing it. And because everything is in JSON format, it's even easier to present in a web application. So what we like to call MongoDB is a multi-model database. And when I call it multi-model, think about it this way. When you think about DynamoDB, you think key value store. That's really it. It's a key value store. When you think about a lot of other popular types of NoSQL technologies, they tend to be that kind of here's a key, here's a value, go get it. And they do it fast and pretty well. But what MongoDB said was, let's get beyond just being key value store. Now we've got all these different types. We can do document data, we can do relational data, which, to be honest with you, was a really, really big jump ahead because almost all data is, in theory, relational. But the fact that you can keep all your relational data in a single document means you don't have to spend a whole bunch of CPU cycles going across multiple tables to get that and join it. It's all within the same doc. Key value store, I mean, we do it because it's the simplistic basic way of actually getting something and retrieving something. We've got it with key value. Geospatial, so let's say you had latitude and longitude and you wanted to index specific geospatial information. Think Foursquare. Think how your maps are actually produced by most of the major applications that you use that do mapping. They're geospatial queries. And then, of course, we got things for good old-fashioned graph. People love graph databases. It is what it is. And, of course, binaries. And you can do things such as work with binary databases to store lots of stuff, say, in GridFS. GridFS is a way to actually store files in a file system associated with your database. So if you want to think about an object store, kind of think about an object store with an image. It's all relative. And this is the thing that separates MongoDB just from about any other major NoSQL database out there in the world. They don't have an aggregation pipeline. Aggregations tend to be something that require a lot of CPU cycles on your application side. You don't need to do it on the application side. We'll do it all on the database side for you and present all your aggregated data before it actually is presented to your application. Here's a really great example of going across multiple fields and getting your results. So let's talk about what's inside your new MongoDB cluster. So you've all, right now, somehow or another, while sitting here watching me, you launched a MongoDB cluster. You probably did it with 3 droplets because that's best practice. So what's going to make up that new cluster? So what we're going to have here are primaries. Primaries are where you're writing your data. Secondaries, that's where your primary is replicating all of your data to. Votes in elections. When one of those secondaries fail, or I should say one of those primaries fail, we need to know what to do and how to handle it. So what we've decided to do is we'll do an election. If you have 3 members in your cluster set, like I said, that's pretty much what we say is best practice to run a production cluster. If one of those nodes fail and it's primary, within less than 2 seconds, you'll see a primary fail over to one of your secondaries, and that will become the primary and continue writing your data. So if you've written a retry and your data eventually goes again and gets handled, you'll be able to ensure that you don't have any downtime in the process of one of your nodes failing. Then we have arbiters. Arbiters are really just what I like to call babysitters. Arbiters sit in front of your 3-node cluster and will say, I'm going to keep in touch with all 3 of you and find out who's most up to date. And I'll be the independent decider of who's going to be the next primary when my primary falls apart. And then we've got hidden delayed secondaries. For us who need to maybe query a database because someone accidentally dropped a piece of data, something like that, having that hidden secondary can be really, really beneficial because you can quickly, without having to go and restore a database, just go query that, get the information back, maybe do a migration, get your data back in, get back to business without having to restore an entire database. And then config servers. You'll learn about how config servers fit more into this as we continue, but config servers are metadata servers. They control where actual data is in the individual clusters within your MongoDB cluster. So this is the basic style of replication that we talk about, and we'll go over what happens when one of these fail. So what we see here is the application and the driver. This will be on one server. And we make drivers for nearly every single language, and that driver is what we call smart client. So if a member of this cluster set were to fail, and you have a full array of the members in your application driver connection string, it'll just fail over. There's no need for you to actually modify the connection string and say, this is my primary now. Not necessary. That smart client will essentially say, you know what? I know that the primary that I had isn't doing anything for me anymore. It's time to move on. And in that situation, we'll have an election. And at the point of an election, we'll go ahead and say, you know what? This guy's the most up to date. We'll pick him, and he'll become our new primary. We'll fix this one. So let's say we take our droplet. We figure out, oh, yeah, we ran out of memory. We restart it. Maybe we resize that droplet. Maybe there was something wrong with it. Who knows? Either way, we'll finish our recovery, and then we'll get it back, and we're back to business. That, it used to be our primary, but now it'll become a secondary. And that secondary will continue to replicate data just like you would expect it to from the primary that's been written since that one's been offline. I'm going to grab your questions right after, no problem. Don't worry about it. So now sharding. Sharding is a funny word that a lot of us hear about when we're talking about MongoDB. There's a hard D, and we're going to stick with that D. But anyway, sharding is a way of actually doing scaling this way instead of this way. So we're going out instead of up to do our scaling. So rather than have our data just live on 3 nodes and continue to just buy bigger droplets, what we're going to do is take droplets and separate portions of our data into them so that we can continue to use the same exact connection string and then have a certain portion of data just handled by a certain collection of servers. And then what we can do is expand that even more. So we can say, oh, all right, now I have even more data. I want to spread it across and make it even more redundant. So I'll have primaries and secondaries for our individual shards. This is how we have redundancy that will be global. So you could take some of these primaries and secondary shard members and geolocate them in other data centers. And then you can use something known as read concern and write concern. And that will actually make sure that reads and writes can be placed in areas that may be geolocated to certain users. That's really advanced use of MongoDB. You can read our documentation about read and write concern. I think it's one of the better options that we have out there for our users. And one of the things that you'll notice here, and we talked about it before, are these config servers. These config servers are working directly with our router, which is a MongoS. And the MongoS basically goes back to these config servers and says, hey, you know, I just got asked for a document. And that document is somewhere on a shard. Where do I go? And they'll say, you know what? It's over here. Go get it. And they'll just get a piece of metadata that associates the data with there. And this all happens nanoseconds, very quickly. You don't need to think, oh, well, just because I'm sharding my data and it's got to go to other servers, it's going to be slower. No. Because you've gone ahead and you've configured certain parts of your application to know it's going to those shards, you'll get the same type of speed and performance that you were expecting. So here's the part that's my favorite. I'm an ops person. I'm a sysadmin by trade, and I love talking about infrastructure. So what we're going to do now is talk about the 3 levels of infrastructure that we have for you. So there's the Ops Manager product, which is you do it all. Then there's the Cloud Manager product, which we'll focus on today, which means we're going to help you do most of it. And then Atlas is another product where we do pretty much everything, but we're not really going to talk about that today. So you got a new database, and you got a lot of work to do. Because these are all things that if you've never used MongoDB, you've got to figure out how to actually accomplish all these things. Like I've built backup systems for one database service, and it was kind of shitty because I had to go and say, all right, I have to build this backup system just to make sure that this one SQL database that I'm responsible for gets backed up. And you know what? It was really not fun because we had to spend thousands and thousands of dollars on commercial licensing. We had to spend tons of money on servers. We had to spend even more money on the actual tapes and disk arrays, things that you would associate with keeping backups for long times. And of course, you know, you've got security, which is a thing that every single person here, if you're working in the internet and you're working with applications, security is something really should be top of mind, period. And of course, you know, we want it to be always online. We want to be able to upscale, downscale, do the things that we associated with a modern database. So, and that's why we have Cloud Manager, and that's what we're going to talk about. So for everybody, since you've all got credits for your DigitalOcean droplets that we saw over there, There's a way for you to use that and that 15 bucks along with Cloud Manager for free. So Cloud Manager is a 30-day trial. Everybody can go on to cloud.mongodb.com, sign up. You'll get your 30 days. There's no coupon, nothing like that. You just get a free trial. So here's what we're going to really talk about how Cloud Manager is going to help you. So here's an example of a web app on the DO network. And what I've done is build it as a MongoDB 3-cluster droplet set, a Node.js 2 droplet web app, and then we're going to forward our web app to our load balancer. I think it looks pretty great. The fact that DigitalOcean added these new tools, they're going to make you capable of building these things faster and quicker. So one of the things that DigitalOcean did that I really appreciate is they've got these one-clicks to build the mean stack. And the mean stack is Mongo, Ember, Angular, what's that N again? Node, excuse me. It's all JavaScript-based stuff. So what you could do if you really wanted to is just take those nodes, build them, put them behind your web app load balancer, and move on. But I don't want to do that. I want to host MongoDB separately from the web stack. And the reason why I want to do that is I want 3 to be in my set. I also would like to have a little bit more control. I appreciate that they have installed MongoDB for us, but I can control MongoDB and use the latest features and latest options along with some of these automated systems that you can use to deploy and back up. So I'm just going to build 3 droplets for myself. And then after I deploy the droplets, I'll get my network configured and I'll build a private IP network within one zone. Because right now, you can't do multiple zone IP transit, so we'll just stick in one. I think that these data centers are fairly reliable, so having 3 nodes in a single zone with the DO network tends to be really solid. You can do cross if you really need to, cross-regional replication, but you could see some potential slowdown just because you're talking to separate data centers. So one of the things I really feel in this particular environment is just stick in the same data center. So then we'll modify our etc host file, or we'll just put it in a DNS. And then what we'll do is we'll find our particular agent that we need. Simple stuff, apt-get install, or you can actually just use Windows. It doesn't matter, as almost every other every major operating system is supported. And after we install our agent, what happens is Cloud Manager calls back to the servers and then says, hey, you're here. Awesome. Now you're MongoDB servers. Our agent is installed. I know where you're at. And I'm going to start helping you become managed MongoDB servers. So what we do after we get our primary automation agent installed is we start adding agents that are going to do both monitoring and backups. And what's really great is it's set and forget. Install the agent, leave it alone. Next, you can build whatever custom cluster you want based on the actual requirements you have. So you can see here, I'm going to build a new replica set. I'm going to use 326 because I'm lame and I'm not ready to use 34. I'm going to specify my port range, and then all you have to do, go on your DigitalOcean side, open up your firewall so that you can access that range. And then what we can do is actually specify right here which members of our DigitalOcean droplets that we want to be part of this set. So I've said these 3 nodes are ready to be added into our cluster. Now, the really, really great thing is this. Let's say in a couple of days, our app is really, really blowing up, and I just want to add another replica. All I have to do is go back into this and edit it, much like this, and just add another member of the option to these member sets. And the reason that it's so easy is we just go by a simple key that you put in a config file when you install by the agent. And that key will say, all right, well, I'm associated with this account. Send us right back to the, call back to home, say, you know what? I found out I'm a new member of this account's MongoDB cluster set. And then it'll just start finalizing your changes and applying. And by the end of it, you'll have a ready-to-go MongoDB cluster set that you can use along with your connection string. Matter of fact, if you just go into the more information, we give you the actual specific connection string to use, so you don't have to guess. You don't have to go through tons of documentation. We've made it so that it's ready to go. So here's the part of it that really, really helps people. So everybody has kind of heard in the last, I don't know, couple months that there's been some issues with intrusions into insecure databases. Now, if you look at the list here, I'm going to show you Couch, Hadoop, Elasticsearch, and MongoDB. What does that tell you? It tells you that it's not necessarily the database that's not secure. It's PEBCAC. Problem exists between keyboard and, or chair and keyboard, exactly. Someone put an application online and didn't secure it. Would you leave, let me show you. If I just do this, here's the money I have in my pocket. You just leave it on the floor and walk away. Am I expecting it to stay there? Somebody's going to take it at some point. The same way you can think about your data. If your data is left open and you haven't secured it in any other way, someone's going to walk by and say, you know what, all those things about a kid's voices and toys, because recently a very, very large toy company had their database cracked because they didn't secure it. Don't add a password. Don't use a firewall. Someone at some point may port scan you. So consider this, and that's one of the great things that Cloud Manager does. So Cloud Manager will allow you to enable SSL. It'll allow you to use multiple security methods such as TLS, or I should say LDAP, X509, standard ScramShell1 for just standard password authentication. So we're talking about stuff that's really, really easy once you use here. Doing it on your own can be fairly difficult, like rotating keys, handling certificates, things like that. The fact is we've tried to take a little bit of that difficulty out of it for you. And then backups. So I was talking about before how building a backup server is really the worst thing to do. It is, because people don't want you to just build backups. They want you to give you restores. Nobody's paying for a backup system that they'll never get working restores from. One of the things MongoDB did was we built this backup system that has guaranteed backups. We'll handle it for you. What we do is we tail your op log. And your op log is where how many of you have used MySQL before? Okay, if you've used MySQL, you'll know that every single time you write a command to your database, it accesses a binary log, a bin log, and it keeps every single current thing that you've written in that bin log. So if you ever need to restore it, you can. Well, MongoDB does something very similar with the op log. And what the backup service that we do is we consistently tail your op log 24/7. So you get point-in-time backups, and we also do a way where you can get snapshots. And the snapshot is literally a binary collection of your database. We'll give it to you in a zip file. You can go and just download it, or you can apply it to an actual running cluster. So if you want to just say, you know what, this cluster's screwed, I need to get my backup onto it directly, you can just point and click and say, let's restore this right back to JDemo number 1. It'll restore my entire backup to JDemo number 1, whether you're here at the DigitalOcean network or you're hosting on Joe's hosting shack. It doesn't really matter. As long as you say, this is where my cluster is and these are where my backups are, you can restore it. No big deal. So from Cloud Manager, we've basically taken away a lot of that burden from you. And we've made it so that you, as the developer, can really write your application quicker, faster, without having to concern yourself with a lot of that operational stuff. So I'm going to start rolling down and getting finished with this. But I want to invite you all. This year we're doing a trade show out in Chicago. We've done it every year here in New York, but this year we decided we want to try a little somewhere different. I was out there 2 weeks ago, and it's a really awesome city. Those of you who know it probably know they got great Goose Island and weird pizza. So if you'd like to come, please do. I got a coupon code there, 25% off your ticket, and let's go get some work done together. I'm telling you, we can. Everyone here, you've got an opportunity to try something new. Like I said, Cloud Manager is a 30-day free trial. DigitalOcean's been kind enough to give you some credit. So together, you can use these and we'll build something. So if you got any questions, I'd be happy to take them. I'm really much better on one-on-one. So let's go ahead and we'll take some questions together while we go ahead and mingle a little, have a little bit more beer, and that's about it. I really appreciate everybody joining me today. Thanks a lot for coming. And if you have any questions, like I said, I'll be over there by the drinks and all that cool stuff over there for you. Please come by and say hello. Thanks a lot. I appreciate everybody coming today.
Yeah, like Jay said, we have probably about another hour and a half in the space if y'all want to hang out. And I'd love to do something a little different than what I have in the past. It's more so I want to get everyone more open and talking to each other. So if anyone has any like pressing news or something that they're working on that they want to share with anybody, or if they're hiring at their company, if there's a like problem that they're trying to solve in some sort of project they're doing, I just want to use this opportunity to, like, for anyone who has something and they want to share with each other.
Oh yeah, and of course we're hiring. Sorry,
No,
we're
it's fine.
hiring. Everybody's friggin' hiring. Come on. Look, you want a job or not? Like everybody's hiring, obviously, and I can only make the compelling chemicals to poisons that could be in your food, to actually finding out whether or not, like I put, whether A-Rod did or did not use steroids. They can figure that out, and they've done that kind of stuff for the IOC. So, like I said, if you want to come work at MongoDB, find me, the guy in the gray right there, or Sean. The three of us will be happy to talk to you. That's all I have to say now.
All right. Anybody from the anybody have anything that they want to share, or anything cool they're working on, company that they work for, if they want to do a pitch of their own? No? No pressure? All right.
Hi, I'm Steve. Thanks. I am co-founder of SmashRun.com, which is a running website. So if you jog, run, any of those things, and you've got Garmin, Magellan, TomTom, Apple iOS apps like, any number of them, we'll ingest your data, and then we'll draw you really beautiful charts and graphs. It's all live and interactive on the screen using D3 with JavaScript. All of everyone's stats are stored in MongoDB. It's sharded, clustered, set it up with Chef. Been using the product since like 2.2, when there wasn't the option for login and password. But now he's right. There is no excuse for not using login and password. But anyway, SmashRun's awesome. And if you're a runner, you should check us out.
Hi, my name is Tindy. I primarily work with a company called Kaggle, but I'm working on a separate project in machine learning with eBay with friends, and it has to do with dynamic pricing and price flexibility, basically, automation of that. So if someone wants to be a guinea pig for an automated surge pricing or price flexibility detection tool, I would be happy to have a conversation with you as to some of the work that we're doing. That'll be cool.
Isn't that what Amazon is storing Walmart with right now?
Yeah. Price. So dynamic pricing and price flexibility is an area of interest right now. So that's one of the things that we're working on. Yeah, cool.
Hi, I'm John Jung. I'm a CTO of a AI startup company in New York. We're funded too, called HelloLucy.io. Right now, I'm in the middle of actually brainstorming of how to set up MongoDB clusters. Got a few ideas, but if you guys want to be, if I can pick your brains, then please come to me.
I'm probably going to hate myself for this, but I work for MTA. I work on the bus time project. So basically, if you have any questions about how Real works or buses work, I'm a software developer. I've dealt with all of it. We use Mongo to store all of the bus time data, including predictions, which I actually wrote. So if you're staying at the bus stop, wondering how long away your bus is, that's me. So I'm good for one-on-one.
Is that open data as well?
Yes, everything's open. And that's actually one of the first projects I worked on.
All right. So let's have some fun for the next hour and a half. I'll put some music on, get to know one another one-on-one, and after that, we'll see you next month for the next meetup.